Hello, this is Ye Lin, and I will explain the homework 6 problem 1. We are given that fx y of x and y equals to a times 1 plus xy when the absolute value of x less than 1 and the absolute value of y less than 1. So we know the domain of x and y is in this square. And the first question is to find a so that the above defined is a valid joint density function. So that means the integral of xy between -1 to 1 finally equals to 1. So we do this integral, and we got that a equals to 1 over 4. And the second problem we need to answer that our capital X and Y are uncorrelated. We know that the CDF of X, we could derive it from the CDF of XY, the PDF of XY, and it's equals to 1 over 2. And the PDF of Y also equals to 1 over 2, because we know that x, y are equal in this problem. And then we could find that the expected value of x equals to 0, because we use the definition and the integral and integrate it, and e of y also equals to 0. And we should do the expected value of x times y, and we use the formula, and finally we got it equals to 1 over 9, because we know that when e of expected value of x times y not equal to expected value of x times the expected value of y, so it's not uncorrelated, it's correlated. And the third question is, are these two random variable independent? We know we calculate the fx, the PDF of x and the PDF of y. So we know that the PDF of xy not equals to PDF of x multiply PDF of y. So they are not independent, they are dependent. And the first problem is we need to find the joint density function of x squared and y squared. We let x squared equals to z and y squared equals to w, and make this problem to the function, the two function of two random variable. And we also know that z in the domain of greater than or equal to 0 less than 1, and w is the same. And the root of this equation is z squared and minus z root and minus z root, and y is the same. So use the formula. We calculate the Jacobi. We calculate this matrix, and we also use the formula to calculate the PDF of z and w. Use this formula, and finally we calculate this, and we got the PDF of z and w equals to 1 over 4 times root of z times w, when z and w in this domain. Finally, we need to the final problem. The last problem is we need to prove or disprove that x squared and y squared are independent, which means z and w are independent or not. So from the PDF of z and w, we could derive the PDF of z and the PDF of w, and in this domain, and equals to this two. Finally, we find that the PDF of z and w equals to PDF of z multiply PDF of w. So that means these two random variables are independent, which means x squared and y squared are independent. So this is the first problem, and we move to the second one. The second question is we know that the PDF of x and y are equals to a, and when x squared plus y squared less than or equal to 1. So that means the domain of x and y is a circle, and it's inside the circle. So we need to find a, and the first question is we need to find a so that the above defined function is a valid joint density function. So that means we integral in this circle, and it equals to 1. So we do the math, and the integral line of y is -1 to 1, and the integral of x is roots of 1 minus y squared to from -1 minus 1 square roots to root of 1 minus y squared. And we got this equation, and we use some techniques make y equals to theta, and change the line, change the integral line. Finally, we got that a equals to 1 over pi. Or we could think, because a is a constant, so that means it's some kind of uniform distribution in this domain. So we know that the square or the area of this circle is pi times 1 square, which equals to pi. So it's just 1 over pi. We could get a. And the second question is we need to find the expected value of x, and we know that. So the first we use the formula, and we found PDF of x, which equals to this when x in this domain. And because x is -1 to 1, because x is an even function, so the expected value we integral this function, and this function is an odd function. But the line is a symmetrical line. The domain is from -1 to 1, so that means the integral is 0. The integral is 0. The same as y. So the expected value of y is equals to 0. and we need to find the expected value when x expected value of x given y. X is a random variable, y is some constant. So we do the math. We find the PDF of x given some constant y, and we use the formula. We find this, then we get that it's equals to some constant. It's equal to some constant, and y is the y in the domain, like this. Also, we know it's a even function because it's symmetrical from minus to from negative to positive, and it's the same. So we know that the expected value is 0. Then we could get that when y is a constant, when y is not a constant, when y is a random variable, it's also equals to 0. So the same as this, we got this is equals to 0, and the expected value of y given x is also equals to 0. But we need to calculate the expected value of x times y, which means we need to do the math, and we also find that this also equals to 0. So the last problem of this question is prove or disprove that x and y are uncorrelated. So from this relation, the expected value of x times the expected value of y equals to the expected value of x times y. So that means they are uncorrelated. Thank you. That's it.